Today in class we looked at geometric figures, dilations, and scale factors. And we learned that a scale factor, when the scale factor was greater than 1, it caused my pre-image to increase in size. When I have a scale factor that is less than 1, it causes my pre-image to decrease in size. So looking at a sample problem number 1, I want to find the image or the value of CA prime after a scale factor dilation of 3 has been applied. Alright, so I need to identify where CA is on my pre-image. Its length was 5 units. 5 units times 3 equals 15. So the value of my CA prime would be 15 units. Same process takes place for AT. AT on my pre-image is 8 units. 8 units times my scale factor of 3. So my AT prime that was 8 units, when a scale factor of 3 is applied to it, AT prime becomes 24 units. The same is true when you have a scale factor that's less than 1. If a scale factor is less than 1, then I still take my value. Let's look at BU. So the distance from B to U is identified as 6 units. Multiply that by my scale factor of 2/5. So 6 times 2 is 12. 1 times 5 is 5. My BU prime, when multiplied by a scale factor of 2/5, becomes 12/5, which is definitely much smaller than 6. We also looked at using scale factor on a coordinate plane. And so when we had a problem like number 4, the first thing we needed to do was identify all our ordered pairs, because we haven't learned anything in 7th grade yet that tells us what the length of each of these sides is. I can identify the straight lengths, but we have not learned a formula that gives us the length of a diagonal on a coordinate plane. So I want to identify the value of my coordinate pair for A. That would be starting from my origin, -1, -2, -3. Now I continue upwards, 1, 2, 3, 4. So the ordered pair for A is -3, +4. B, starting again at the origin, -1, -2, -3. Continuing down, 1, 2. So that would be -3 x's, -2 y. Point C. I don't move left or right at all, so that's going to be a 0 on the x, but I do move down 2. So I've identified ordered pairs for all 3 of my points. Next thing I'm going to show you, I'm only going to apply it to A, but you can apply it to every one of your ordered pairs, is the scale factor. So for the scale factor, we take each ordered pair and each value within that ordered pair and multiply it by our scale factor. So our x value of -3 times 1/2. Negative 3 times 1, that's still negative 3. 1 times 2, that would be 2. So my A prime value would equal, for x, negative 3 over 2. I need to do the same thing for my y value, so I have a 4 for my y value, times 1 half. 4 times 1 is 4. 1 times 2 is 2. 4 over 2 simplifies to 2. So I have an x value that's my a prime and a y value that is a prime. Well, that's another coordinate pair. I can go ahead and graph that. So negative 3.5 would be negative 1.5, negative 1.5, up 2. And I will label that on my graph a prime. Now you can follow the same process for each of your other ordered pairs, and you will have a triangle that is dilated with a scale factor of 1/2. Last thing I want us to look at real quickly is proportional shapes. I have two triangles in which I have gone ahead and told you that they were similar figures. And since they are similar figures, corresponding sides on each of these similar figures will be proportional to each other. So I can set up a proportion of the right side of this triangle to the right side of that triangle, and say that 2 is to 3 as x, starting with my small, is to its corresponding side on the large, 12. So my small side on the triangle, my small side on the bigger triangle, is proportional to x over 12. And now I simply cross multiply. 12 times 2 is 24 equals 3 times x, 3x. Divide both sides by 3, and we find that x equals 8. My missing value right there is that side of 8. You can perform that same process on each of the following figures to identify the missing value.